On tonight's homework, students are going to be practicing adding mixed numbers by thinking about the numbers instead of as mixed numbers, but as a combination of different units. So whole numbers and then fractions. So you can see in problem A, they've broken the mixed numbers into its whole number component and its fraction component and then combine. So you see here they did 2 and 1 became 3, 1/3 and 2/3 became 3/3. And then the second step of that is to say that this is equivalent to one whole. So it should be like 3 plus 1 equals 4. So students can continue that model of breaking it into whole number plus the fraction and then combining. So here thinking about what those two whole numbers add up to be, and then what the two fractions add up to be. And in this case, because it's plus 4/5, we would just keep it as 4 and 4/5. There's no exchange. Okay? For this one, the kids are doing the same set of work, except they're breaking the work into a number line. So here, I would show this as 2 and 2/4. This is 1 and 3/4, and I would show both whole numbers first. So I would show going out to 2 and then one more. And then I can think about 2/4 and then 3/4, which I can see brings me out to 4 and 1/4. I can also see that from here. So I got 3 and 5/4. That exchanges. This 4/4 is the same as one whole, so it would be 3 plus 1 is 4 plus 1/4, getting that same answer. So students are going to want to solve both ways for these two problems. So first, solving using the number model. So here 3 and 4/6, 2 and 5/6 combining. My two whole numbers combine to make 5, plus my fractional part will be 9/6. I'm going to do the same thing I see up here. I'm going to break it into what makes one whole. So in this case, the 6 tells me 6/6, and then I'm left with 3/6. So I know the 6/6 becomes one whole, so I should get 5 plus 1 plus 3/6 for a total of 6 and 3/6. For the number line, students can choose to do it two ways. They can choose to go from 0, or like the one in the problem above where they just start at a number kind of prior to it. I think it makes more sense for me, excuse me, to show the whole number line. So to do that, I'm actually going to move to the space below so you can see it. So here I want to show 0. Here I'm going to show this is a little bit more than 6, so this should be 7. That way I have enough space. So I'm going to show 5 plus, or I'm sorry, I'm going to show back up to here, 3, oops, wrong problem, 3 plus 2. So I'm going to show out to 3, 2 more, that gets me up to 5, which is how I got here. And then I'm going to add 4/6. Well, to do that I need to break this into 6 equal parts. The reason is because my next part is that I'm going to add these two fractions. So I need to be able to see fractional parts, and in this case it's 6. So I'm first going to do 4/6. That brings me to 4 and 4/6, and then I need to add 5/6. So I need to say 1, 2, 3, 4, 5. That brings me to here. And I can see how that matches my original mathematical problem of 6 and 3/6. So the number line is a way for students to see how the what we did here, how this decomposition of the fraction and exchanging it for a whole number looks on a number line. They can see how this is still a fractional part. This was still 4/6, and this was still 5/6, but they can see how those two combine for something greater than one whole. And then here, this is something a lot of us didn't get to in class, so it's an important part of the video to see. So we're going to add up the whole number and see what it is that we got to before we add the second fraction. So in this case, they added 2 and 1 and got 3, and then they kept the fraction of 3/4, and then thought about what this one was as a decomposed fraction. So let's do that here. We have 2 plus 3, that equals 5, and we're going to keep the fraction of the first number, 7/8. And what we're thinking of, what they're showing you here, is what do you need to do to get to the next whole number? So for us to get to the next whole number, we first have to know what the next whole number is. We go from 3 to 4, so we should go from 5 to, if you said 6, you're right. If we go to 6, we need to say to ourselves, how do I get from 7/8 to the next whole? Well, we do that by adding 1/8. Well, so what we need to do over here in the fraction is saying, well, we didn't have 1/8, we had 4/8. Well, 4/8 is the same as 1/8 plus 3/8. So I use this 1/8 part of the 3/8 here, which means I must have this part remaining. So that tells me that I have 6 and 3/8. So it's a different model for thinking about how to get to the next whole number. So again, we can add the whole numbers here. We see 1 and 4. It's 5. We're going to take the fraction, 7/9, and ask ourselves, how do we get to the next whole? Well, what's the next whole number? After 5 comes 6 again. How do we go from 7/9 up to 6? Well, 7 plus 2 gives us 9/9, which tells me I use 2/9 out of the 5/9, which if I use 2, I must have 3/9 remaining. So I knew to make this 2/9 because that's how much I needed to get to the next whole. This is the part that remains, so it becomes the second part of my fraction. And then on problems 4, for A, B, and C, students can use any method. They can simply use the number model, they could use the number line, or they could use the method that I just showed you, which is using the arrow to make one more.